Hello, my name is Turner. I'm a rising senior at Colorado Academy, and this is my project, the Audio Spectrum Analyzer. So this is my processing code. This is the part of the code that does the FFT, or the fast Fourier transform, on the incoming audio signal. And so for this milestone, I'm going to be explaining my better understanding of what a fast Fourier transform is and how it works. Here I have two graphs to help me explain what the FFT does. So a normal audio signal, or a basic sort of sine wave audio signal, looks something like this, where this up and down motion here is a change in voltage across the time domain. So as time goes on, it shows you the changing voltage. But that's not very useful when it comes to looking at the sort of spectrum of audio. So what an FFT does is it takes this sort of changing voltage here across time and converts it from the time domain into a frequency domain, so that instead of a bunch of peaks, you get one single peak, and this peak here represents the amount of voltage change at a certain frequency. Now another use of the FFT, or another application of it, is when you're looking at a square wave. So this square wave here, when converted to an FFT, would look something like this, with lots of peaks that slowly decrease in magnitude as you go along the frequency domain. The reason for that is that if you look at this square wave, it is actually a combination of many different sine waves that have been put together. So you take a large sine wave like this and add to it a second smaller sine wave like this one, where you have two peaks for every one peak of the first sine wave, and you keep repeating this process with smaller and smaller sine waves until all of the sine waves eventually add up to look something very similar to this square wave. And if we go back to the previous page, the reason that you get these lots of peaks that slowly decrease is from all of these sine waves. So the first large sine wave is represented here, and then the second smaller sine wave is here, third even smaller sine wave is here, as you can see right here, the larger, smaller, and smaller. So my next goal for expanding my project will be to write more Arduino code that gives my audio spectrum analyzer more than one use.